Hey guys, today we're looking at 3.7, which is all about graphing absolute values. So now this section is a little bit condensed from what I usually do, and we'll also skip 3.6 this year, it's the most complicated section, the one that we're skipping, but it also does make this section a little bit easier once we've gotten through that difficult part. So I'm hoping this year that we can still kind of skip that section without missing too much in terms of section 3.7, which is all about graphing absolute value functions. So to start with, we need to get an idea for what an absolute value graph looks like. Now, if you remember, absolute value makes everything positive, right? It talks about the distance away from 0 on the number line. So what I'm going to be doing is my x values are going to be put into my function inside the absolute value bar. So this function right here, f of x equaling the absolute value of x, that is what we'll eventually call the parent graph for an absolute value function. So eventually down the road, more so in Algebra 2, we talk about parent functions and then transformations, which is what 3.6 was about. So what basically we do is we take this simplest version of our function and then just do some stuff to it. We move it around, we stretch it out, we make it shorter than it usually is, we flip it over, that kind of stuff. Now you guys did do transformations in 8th grade. I think it's 8th grade you guys usually do it, so it should be semi-familiar to you, but I'm going to try and do my best to be able to graph these without talking about them in terms of transformations. So to start with, let's get an idea for what the graph looks like. Just absolute value of x, the simplest version of an absolute value graph. In order to figure out what it looks like, we need points, right? Before we knew what any kind of graph looks like, we can just pick out some x values, plug it in and get some y values, so we get an idea for what the shape of the graph looks like. So if I do that with these functions, or these x values, -2 to +2, if we plug those numbers into my equation, basically, I'm just taking the absolute value of those numbers. So the absolute value of -2 is +2. The absolute value of -1 is +1. Absolute value of 0 is 0. 1 is 1. 2 is 2. So those are then coordinates. If you look at x comma y, we've got the coordinates -2 comma 2, -1 comma 1, 0 0, 1 1, and 2 2. So to get an idea for what the graph looks like, I'm just going to go ahead and plot those points. -2, +2, -1, +1, 0 0, +1, +1, +2, +2. So you can see it kind of makes this little V shape, and if I picked out numbers bigger positive and bigger negatives, I would continue getting this V shape of my graph. So if I grab my ruler and I line these up, this is what my graph looks like on the right, sorry, the left side. And then I flip it over here, do the same thing on the right side. So this V shape is what my absolute value graph looks like in general. Now, we won't always have it look perfectly like that. Some things to notice here with our absolute value graph. We have this point of my V, kind of where the V originates from. It happens here at 0 0. We call that point the vertex of my absolute value, because all of my points originate from there and then kind of go off into that V shape in either of the two sides, the left branch and the right branch. Now, the other thing to notice here, if you look at kind of the slope of each side, it's the same slope, just opposite sides. So I'm still, like if I was going to go from one to the next, my slope triangle is up 1 over 1 on the right side, up 1 over 1 on the left side as well. It's just that you're going up 1 and then right 1 on the right side, up 1 and left 1 on the other side. So we've got some of those patterns in here, and that happens because we have symmetry in our graph. So the vertex is the kind of the center of my graph, and it's symmetrical on both sides. So when we go through and graph these, when we have different things happening, we're going to start by graphing where that vertex happens, and then we'll be able to identify what the slope is on either of those two sides to be able to graph the rest of it. So in order to do that, we have this format of different things that can happen to my function. So we still have my absolute value bars, absolutely true. My x is going to be inside those absolute values, and my y is going to be on the other side of the equation all by itself. But we've also got these three values in here, a, h, and k. that are going to do things to my graph. They're going to move it around. They're going to make it look a little bit different, a little narrower, a little wider. Maybe it opens down so it's more like a mountain instead of a V. So all of those things adjust how my graph looks. The important one, or I guess the thing we start with first, is where that vertex happens. Remember, that's the center of my graph. And h comma k is where that happens. If I'm going through and finding in my function, my formula, my equation here that I'm going to highlight in blue, my h and my k, my h is always whatever was subtracted from x inside my absolute value bar, k was whatever was added on the outside. So here, the tricky part of this is your signs. So if you see it as a +3 on the inside, it's actually a -3 because we're trying to figure out what was subtracted from x. So it takes some getting used to, but so the other thing is, once we have our absolute values vertex, once we have that h and that k, the next part is our two branches. Now our two branches, like we said, have the same slope on either side. It's just, positive or negative going up and then over in either direction. And then the number that tells us how that happens is a. That number that's out in front of your absolute value, whatever that number is, that tells us what the slope is on our branch. So in example number 1, just putting some practice in here, we need to figure out what a, h, and k are. And again, those numbers are the number in front of my absolute value is my a value. Here we don't see anything, which we know from our equations when we're doing graphing lines. If I didn't see a value in there for m, we knew my slope was 1. So my a value here is +1. Now, the h value here is tricky because it's always x minus h plus k. And we can kind of write that there as a little reminder. So if I see it as x plus 2, and I have to try and think of what was subtracted there, well, we know that subtracting a negative is the same thing as adding a positive. So in this case, my h is actually a -2. It's always the opposite of what you see there. If I see it as x plus 2, it's a -2. If I see x minus 1, it's going to be a +1, because +1 is what would be subtracted there. For my k value, that always matches exactly what it is on the outside. So if I see -3, my k value is -3. If I see +5, my k value is +5. So utilizing this information now, h comma k is my vertex. So, h comma k is my vertex. So that means that -2 comma -3 is where the point of that graph happens. Left 2, down 1, 2, 3. This point right here is where my vertex is. That's where the point of my graph is. Now from here, we just apply my slope. If my slope is +1, which we know means 1 over 1, from here we can go up 1 over 1, up 1 over 1, up 1 over 1 if we want to continue doing more points. But since that's only 1/2 of my graph, I have to do the same thing on the other side. Up 1 over 1, up 1 over 1, up 1 over 1. You can do as many as you want to, as long as you have the vertex and a point on either side. Then you'll be able to grab your ruler, come right in here, and you're going to go ahead and move your ruler over this way, line it up nicely here, and arrows on the ends, and that is my absolute value graph for that particular example. Okay? We're going to do some more. It takes some getting used to. I totally realize that. And I can tell you now, there's only one of these problems on the test. So temper your confusion. Temper your frustration. Okay? All right. For number 2 here in box 3, here we've got some different things happening. I still need to figure out my A, H, and K. And if you want to write these out, you can. If you don't want to write them down and explicitly label it, that's fine too. My A value here, we actually see something now, is actually 1 over 3. So our slope is going to be 1/3 on either side. My K value is whatever was subtracted from x on the inside of my function. Now if we look here, there's nothing happening inside my absolute value besides x, which means my K value is 0. And then my h value is 0. My k, I'm subtracting 4, so still negative 4. So that tells you that my vertex of my absolute value is going to be just at 0, negative 4. So left to right 0, down 1, 2, 3, 4. That point right there is my vertex. Now I just apply my slope. My slope is 1/3, which we know 1 over 3. If it's a rise of 1 and a run of 3, that's up 1, right 3. So up 1, 1, 2, 3. Up 1, 1, 2, 3. I usually do 5 just because it helps me line it up a little bit easier. And if I know that's the right branch, I know my left branch has to follow the same pattern. So up 1, 1, 2, 3. Up 1, 1, 2, 3. And then again, I grab my ruler, try and line it up nicely. Make about 18 degrees on my ruler, which means we'll go over here the same thing. 18 degrees. Line it up. Straight line. Yeah, buddy. Here we go. All right, last one. Ooh, last one. All right, here we go. So once again, we need A, we need H, we need K. Now my A value is -2. My H, since that's the thing that was subtracted from my X value, is a +1 this time. All right, if it's X minus K, or X minus H, and it's X minus 1, H is 1. And then here now my K value is a +3, so +3. So when I go to graph my vertex, the point of my absolute value, I'm going to go right 1 and up 1, 2, 3, that point right there. And now my slope, since it's -2, we can turn that into a fraction by doing it over 1. That means I'm going down 2 and to the right 1. So now from this point that is my vertex, I go down 1, 2, over 1, 1, 2, over 1. And if I know that's what my right branch looks like, the right side of my graph looks like that, I know down 2 over 1 the other way, down 2 over 1 the other way, is what my left side looks like. So now if I go ahead and grab my ruler, I'm going to go ahead and line it up best I can. Looks like about, for me, 64 degrees. Looks about right. All the way to the edge. We'll go the other way, 64 degrees. There we go. Line it up all the way down there. Arrows on the end. There we go. So some things to notice here. Because my slope was a negative, my V is now a mountain instead of a V. My absolute value graph is opening down, pointing down instead of opening up. So that's always going to happen. The other thing to notice here, looking at my slopes, a 1/3, so a fraction, made my graph, my V shape, wider. And the bigger my number was, +2, made my V shape a little more narrow, a little more steep. Which makes sense. If we're talking about the numbers themselves, a small slope is a flatter line, which means it's going to be a flatter V. A steep slope, a bigger slope, is a steeper line, which would make a more steep V. Your homework tonight, I decided not to do any bookwork homework for this section. So for 3.7 for this first one is 3.7 practice A is a worksheet that I printed out and sent home to you guys today, or you should be receiving on Thursday, depending on when you're watching this video. And then tomorrow, which would be on Friday, day 2 of this section, will be another practice day, a practice worksheet that I also sent home for you guys. So that's all I got for you for today. If you guys do have any questions, as always, make sure you guys are reaching out and letting us know. If you have any questions, concerns, thoughts, ideas, hopes, or dreams. And if you don't, then I'll see you guys in class and have a fantastic day.